Okay, resuming with number 6, zero product property, which is A times B equals 0, or if A times B equals 0, then A or B must equal 0. So we're going to use that the whole way through. So I know that x minus 8 equals 0, or x minus 4 equals 0. So that means x equals 8, or x equals 4. Next one, 2x minus 12 equals 0, or 6x plus 4 equals 0. Solving for x, I have 2x equals 12, x equals 6, or 6x equals negative 4, and x equals negative 4 6, which is 2/3. This one, 4n equals 0, or 3n minus 9 equals 0. So we know that n equals 0, or 3n equals 9, which means n equals 3. So done with those. Solve. So this is using any method we know of. Well, I could factor it using AC. So factors of 12 that add to negative 7. Let's see, 1 and 12, 2 and 6. Well, 3 and 4 work. Negative 3, negative 4. You could also use the quadratic formula. I'm going to go ahead and factor. I think it'll be maybe a tad faster, although I usually use quadratic formula for AC problems, except that 3 and 4 is such a small number that it was pretty easy to figure out factors that add. So we ended up with negative 3 and negative 4. And so I'm going to make my box. So 3z squared, 4, negative 3z, and negative 4z. Factoring that, I come up with 3z, negative 4, z, and negative 1. So my factors are 3z minus 4 times z minus 1 equals 0. Now I can use the zero product property, and I get 3z minus 4 equals 0, or z minus 1 equals 0. So 3z equals 4, or z equals 4/3, or z equals 1. Done. Alright, moving on to number 10. Solve. Using any technique necessary. I notice since there's no b value, the easiest thing to do is going to be to add 1 to both sides, take the square root, and bam. So now you can check it. So 1 squared minus 1 is 0, negative 1 squared minus 1 is also 0. Now on this one, it's the same as the last one basically, except that the directions actually tell you. Use square roots. So there's no b value again, so we're going to subtract 45 from both sides and get, what is that, 36. We're going to divide by 4 and get 9. Take square root, and so we know that x equals plus or minus 3. And you can plug in both of those. 9, 36 plus 45 is 81, and plug in negative 3, same thing happens. Alright, so down here, same stuff. We're going to isolate the squared x value by adding 8 first, dividing by 2. X equals plus or minus 2 because we take the square root of both sides. Alright, getting into our first word problem here. The area of a playground is 221 yards squared. The width, okay, so I'm going to first draw a picture. Now I know that this area is 221. Width is 4 yards longer than length. Okay, I know the formula for area of a rectangle is length times width. So now I'm going to can't use the zero product property because it's not equal to 0 yet. So I'm going to make it equal to 0. Now I can't use the zero product property because these aren't factors. So I'm going to move over here, and then I'm going to use the distributive property to turn these into factors, or sorry, to turn it into a trinomial, which we can then turn into factors if we like, or we can use the quadratic formula if we like. Let's see, 221, it's going to make the quadratic formula kind of large, so I'm going to see if I can find factors that add. So 221, looks kind of like a prime number, but I'm not sure. So let's see, 221 divided by maybe 13. Sometimes when you get a large number that looks prime, the easiest numbers to divide by are some of the prime numbers that we don't usually use, like 13, 19, 17, because it's pretty clear that it's not divisible by some of the normal things like 2, 3, 5. So let's just try this here. 13, 91, I don't know if that goes in, so let's see, 130, 39, okay, I think it does. I think it goes in 7 times. Yes, it does. So 17 times 13 works. So we have L plus 17, L minus 13 equals 0. So L is going to equal negative 17, or L equals 13. This one is not, we're not going to worry about that because the length is not going to be negative. However, it kind of shows up again because the length is 13 and the width is going to be 17. And that is what we're looking for, so we're done. And these are yards, so we should put that in our answer. So now we're done. Alright, value of c to make it a perfect square trinomial. You take half of b, which is 3, square it, so c is going to equal 9. Okay, here's one that it seemed like everybody was having a lot of trouble with, but I think you'll find it's going to be super easy. So let's see. An object is dropped from a height of 144. Use the equation below to find how long it will take for the object to hit the ground. Well, the ground is at a height of 0, so we plug in 0 for the height, right? T is the time, h of t is the height. So 0 equals negative 16t squared plus 144. Now we can solve this a number of ways, but since there's no b value, I think using square roots is going to be the easiest. So I'm going to subtract 144 from both sides. Divide both sides by negative 16. I don't actually know what the answer to that is, so let's do some long division here. Well, that's not going to help either. So let's see, 16 times 10 would be 144, so, 16 times 10 would be 160, so times 9 must be 144. So we have 9 equals t squared. So the square root of both sides, so we're going to get t equals plus or minus 3. Since it's not going to take negative 3 seconds, we know that it is going to take 3 seconds. And we can plug that in. So 3 squared is 9 times negative 16 is negative 144 plus 144 is 0. Moving along, now we got Catapult launching a boulder using the equation. We're talking about maximum height. So we just need the x equals negative b over 2a. In this instance, x is actually t, so we'll say t equals negative b over 2a. So negative b is negative 100. 2 times a, so that's negative 32. So let's reduce that. So we can have 50 over 16, or 25 over 8. 25 over 8. Okay, let's begin. So h is going to equal negative 16. I'll just make it a fraction, times 25 over 8 squared plus 100 times 25 over 8 plus 30 over 1 for now.